In this tutorial, we're going to take a look at how to use CMake combined with a Unix or Linux environment. Specifically, we'll be using the ECE3 server at the University of Arizona. The first thing we need to do is actually connect to that server. We can do that using the SSH command. If you're on a Windows machine, you can use a secure shell client or PuTTY as a program to connect to the ECE3 server. So we're going to provide our username here and then specify the server we're connecting to. The name of that server is ece3.ece.arizona.edu. We can then go ahead and log in. Now we're on the ECE3 server where we can take a look at our project. In our home directory, we have a directory called Spacer. That's going to be the directory in which we have all of our CMake files along with our source files. So we can go ahead and change directory or CD into that directory. In that directory, we start off with two main things we're looking at. The first is a CMake file. This is the file that specifies the commands to CMake. So if we take a look at that file using the less command, we can take a look at exactly what's happening in this file. The first thing, we have a version setting here just to specify what version of CMake that we want. We then have a command to CMake that tells us to create a project and to use the name spacer project for that project. And then we additionally have a command that says add subdirectory src. src is the directory that CMake will then go into and look for an additional CMake list.txt file to determine how to build our program. So if we cd into that src directory, we can take a look at the files that are in there. We have 4 source files. In those source files, we have, in addition to those source files, we have a CMake list.txt file as well. If we look at this CMake list.txt file, we have 3 commands that we're using in here. The first command will set the compilation flags. The -wall flag tells us to turn on all warnings. That can be useful for understanding possible errors with our program that are not compilation errors. The -g will allow us to generate debugging information so we can debug our program using a debugger. The second command is the file command. The file command here will search the current directory for all .c and .h files. Every file that ends in a .c or .h will be combined together into this variable srcs, or sources, and then that variable will be used in our final command, which creates an executable. The name of the executable is spacer, and spacer will be built using all of the .c and .h files previously found. So for us, we're going to have a directory. All of these files here will then be part of our commands. So to run CMake, we're going to go back one directory here to our top level spacer directory. But we don't want to just compile all of our programs directly in this. We want to separate all of the files associated with our compilation into an additional directory. We're going to call that the build directory. So we're going to create a directory called build, and then we're going to cd into that directory. So we're now in the build directory, and we want to run the CMake command directly inside this directory. So I can run CMake. The location of the top level CMake list.txt file is not in the build directory, it's one directory up, so our command is actually CMake ... When we run this command, CMake is going to essentially search for a valid working compiler on the system. In this case, it's looking for GCC. It's going to actually test to make sure it can compile a program. Once this process is done, we will then have CMake generates what's called a makefile project, or just a make project for short, which is stored in this file called makefile. We're not actually going to take a look at that, but you can go ahead and take a look to see essentially what we're trying to avoid having to manually write ourselves by using CMake to generate that for us. So now that we have the makefile project created, we can then run the make command which will actually compile our program for us. So when we run this make command, we can see it compiling all of our .c files. It compiles the C file into object files. For each C file, you generate one object file. And then finally, it's linked together to produce our final executable spacer. I can now run that command by I can now run the executable that we just created by using /source/spacer. So the dot tells us to run the command within the current directory. The source is because the executable will be located inside the subdirectory source inside build, and then spacer is the name we actually gave to the executable. So if we run that program, we now see that this prints out a usage statement because our program is expecting to have multiple inputs. We have command line arguments. It's expecting an input file along with an output file. So to run that with an input file and output file, we could have provided an input file and provided an output file and run our command from in that specification. In this case, those files don't actually exist, and so it's going to produce another error message saying it can't open the input file. But if you provide the correct path to your input file, the program can then run the operations on that. That's the quick basic introduction to how to use CMake, along with how to use the make command. If you had made additional edits to your program, you could simply recompile your program by typing in make again, in which case it would check to see if any of the changes were made to your source files, and it would rebuild the executable.